complex numbers. Now I would take theory of equations. So I think theory of equations, yesterday sir has touched upon some quadratic equation, roots, what is the importance of roots. So my job is simplified. I would just give you some, just this is a pictorial representation of a polynomial, right? This is a polynomial of, this is a polynomial equation, and this is the graph of the polynomial, and where this graph touches the ground or touches the x-axis, we called it as a roots of the equation. These are these points represents roots of the equation. How do you get the roots? We equate the given equation to an 0, and then we get the okay, then we get the solution to the roots of, we get the roots of the polynomial equation. So very simple. Let us begin about the theory of equations with a very simple linear equation. So two trains leave the station at the same time. So there are two stations. Okay, there are two trains. Okay, which are two trains leave the station at the same time, traveling in opposite direction. Okay, they actually I think you can see that this one, yeah, they are traveling in the opposite direction. One travels at 70 miles per hour, the other travels 60 miles per hour. How long does it take for the distance between them to reach 390 miles? So this is moving this is moving in this direction, this is moving in this direction, and now what is they are starting from the same station, and now when is the distance between these two trains, they get 390 miles. Okay, so 390 miles is fixed now. Now I need to calculate the distance. So now you know that this is moving at the, so now it is a very simple algebraic equation, right? Linear equation. Now I can say that so the distance traveled, you can see that here it is 70t plus 60t equal to 390. So now yeah, so now by simple, right, you now substitute 70t plus 60t, it becomes 130t equal to 390, then t equal to the whatever the value you try to get it. Okay, so these two, when you get these two values, okay, these two values, you can get the t value very easily. Okay, so after these many minutes or these many seconds, these two trains, they are at 390 miles, okay, distance. So that is how in real life we try to solve different problems. Okay, and another very this is actually this I have already discussed about how to recover the document from a noisy image. So this is a noisy image. If I give this image and tell you to read, it is not possible for you to read. However, I told you that at IIIT Allahabad we have come up with equation. So this is the equation which we have come across. So this is the reference available. You can see that enhancement of variably illuminated document images through noise-induced stochastic resonance. Stochastic resonance is a physical phenomenon which we have tried to model it using this particular formula. Now you plug in mean value and standard deviation value, you get what is the noise to be added to this particular document, and to how this document from this one. See, now here I told, just remember my previous example which I gave you from the board. You have to extract the equation. There the reference image was available. In this case there is no reference image, so you don't have the reference image here. You don't have an original copy of the image, now original copy of this book. So now you need to design a technology to recover without taking the reference image. So we use this particular equation. Okay, this equation is used to predict what is the amount of noise to be added. So for this, so you can, for detailed explanation, you can go through this research paper of ours which we published in the year 2019. You can see that. So another application of linear, okay, equation, theory of equation, is that it is proving that so this is a very common example which is available in the textbooks. You have a line, okay, you have a line, and when the line intersects a circle, it meets, you want to prove that it does not meet the circle for more than 2 points. Okay, so you have to prove that the line touches the circle at only 2 points. Okay, so now how will you do that? Now you have equation of the circle, x square plus y square is equal to r square, and then you have the equation of the line y equal to mx plus c. Simply substitute this y equal to mx plus c in here, and then you solve the equation. It becomes a quadratic equation. And you already know that when it becomes a quadratic equation, it has only two roots, and that two roots are 2 points on the circle. So this proves that this a circle meets a line, or in the sense when the circle bisects when the line bisects the circle, okay, it meets okay, at maximum at 2 points, not more than 2 points. Okay, so the other case is very different, where actually you can the circle means the line meets a circle at the one point, that is called the tangent. So that is a different okay, a different application. So tangents have a lot of applications. I'm not going to discuss. The whole optimization problem, machine learning problem, deep learning problem is about the computing tangents and optimizing it, reaching the minima, reaching the maxima, and all these problems are here. Okay, so another very important application of theory of equation is the defense system. I think I gave you a clue here that, okay, what is the, okay, now you have designed a defense system and you want to fire a missile from a particular place and you want to hit that particular target. So now you need equations. And what kind of equations? It is quadratic equations. So so similarly, you can also take an example of a ball thrown straight up from 3 meters above. I think this example was yesterday told to you by director sir also. So if you are throwing from ground to ground means one root is root of the quadratic equation is on the ground where you were 0, and the other side is the hitting target. But here, if you are at a 3-meter height, then you have only you have one positive root, the other one is a negative root. So positive root will tell you the where to hit the target. Okay. And negative root is that when you come, I think yesterday sir explained to you that if you come in the backward direction, if you extend the curve after 3-meter height, then it will definitely touch the x-axis, and that is the negative root. So defense system uses all kind of mathematics. And now you take the example of our Vikram launcher. Okay, the ISRO launched Vikram satellite. So Vikram satellite also we had a wonderful presentation from the ISRO at IIIT Allahabad. So I was fortunate to attend that. So I saw that full of mathematics, full of quadratic equations, full of algebraic equations. Okay, so launching a satellite onto the onto some orbit is full of mathematics, calculating physics, so many things it involves. Okay. Another very interesting example of quadratic equation is, so this I could get it, is this actually what we call a reflector antenna. You can see that reflector antenna is parabolic in nature. Okay, so the shape is like a parabolic curve. Okay, for a parabolic mirror, a reflecting telescope or satellite dish, the shape is defined by a quadratic equation. Quadratic equation are also needed when studying lenses. Okay, so they're also in quadratic shapes and also the curved mirror. So this is one very beautiful application of quadratic equations. So another beautiful equation is that you want to okay, you want to design something. Okay, you want to design some football ground or something you want to design which is in rectangular shape. And I will just read it because you also have some practical problems after this lecture. So there also you will learn a lot of things, how in practically these things are used. So here the whole issue was that the length should be 3 times greater than the I think length or width. I think okay. Yeah, we want the width of the field to be 3 feet longer than the length of the field. Okay, so this is the equation we get, x into x plus 3, but whereas the area is fixed 75. Now if you solve this problem, then you get that what should be the okay, length of the field. Okay, what should be the length of the field is being derived from this equation. Okay, now another important problem which is very popular, like we every day we buy objects, I mean we buy very things from Amazon, from Flipkart. Okay, the major problem now, you know that the robots are delivering, okay, robots are fetching goods They are transporting goods in the Flipkart or the Amazon, what we call the godowns, okay, the place where they keep the object. Okay, so this is automated. Now you have some object and you calculate the volume of the object, and now after calculating the volume of the object, now you have to get the proper box to package it. Okay, now in this case you can see that breadth of the base is fixed, length of the base is x plus 6, height of the base is, so this is some standard cartoon which is available. Okay, so now what is the value if you are able to, so we have to solve this equation such a way that the volume occupied is 2618. Okay, so this is a very simple equation, and if you solve this x, okay, able to find the x satisfying the above equation, then we can easily, okay, know that what is the size of the box which is required to fit this particular object. Okay, so this is a very interesting example which is used in our day-to-day life. Okay, packing a material. Okay, packing a material. And another very good example is that weather forecasting. Okay, so unfortunately, this is not the temperature of Tamil Nadu, because Tamil Nadu does not have this variable temperature. Actually, we can relate to Allahabad. So in Allahabad, winter is very cold. Winter goes in winter we have a temperature of 3, 4, 5 degree Celsius, and in the summer we have around I don't think so. This is in Celsius degree temperature. I think this is some other, but let us assume that this is the minimum and maximum temperature of a weather. Then we can see that this is a lower temperature is a higher temperature. So in summer nowadays in May and June we have a very high temperature. It goes around 49 degree. So now if you model a spline or a polynomial interpolation, if you try to do for that particular data, you can easily predict, okay, what will be the what was the temperature in 10 years back, 50 years back, 100 years back, what is the temperature that will be in next year, next month, or next day. So all those interpretations are this is used in so we use splines. Okay, splines or polynomial interpolations is used to for solving this kind of problems. Okay, these are very extensively used in data science problems. And now in another very important okay, see, in life it is not that we deal with only one equation. Okay, in life we deal with many equations simultaneously. So many equations simultaneously gives rise to linear algebra, right? So if you want to solve many simultaneous equations, like for example, this is a linear equation is very popularly used in avoiding collision in the flights. So flights are moving in different planes. They are moving. So each is a vector or each is an equation. So different flights are flying at different path, and now the controller ensures that the path of the flight should not meet. Okay, that means they should not collide. So similar application, there are a lot of applications of these simultaneous linear equations, and one example which I can give you is that, so you can run 0.2 kilometers every minute. The horse can run 0.5 kilometer every minute, but it takes 6 minutes to saddle the horse. Means this is a seeding time. That means the horse, you started running it, whereas the horse is been prepared, and then it will run after 6 minutes. Okay, and then but horse runs faster than you. How far can you get before the horse can catch you? So this is one way of modeling d equal to 0.2 t. This is your case, whereas in this case, in the horse case, it is 0.5 t minus 6. Right? See, now you have learned that see here, this is very interesting. This is minus 6 is being learned from the property of the horse, or the feature of the horse, the problem of the horse. So this is how we formulate the equations, and when we try to, so when these two equations meet, that is the point where the horse will catch me, and and that is the distance which I'm, so intersection point, that is the x equal to or t equal to 10 is the point where we are going to meet, the horse is going to meet the person, right? So this is very interesting example. Now I have covered all the many applications related to algebra, related to complex numbers, and related to theory of equations. Now I would give you a new dimension. Now, see, now we are entering into the age of data. Okay, in the era of data. So why I have put this slide is that because mathematics drives this entire data science. If you are bad in science, then you please forget data. You cannot process the data. So now let us see that how Clive Humbe, okay, he was the first person to use this phrase called data is a new oil. So data is the oil of the future. It is valuable, but if unrefined means you are not using mathematics. If you are unable to use good mathematics, if you are unable to use good modeling, unrefined form, it cannot be really used. Okay. So it has to be changed into gas, it has to be changed into plastic, it has been changed into chemicals, etc., to make it more and more valuable. Okay, this is crude oil. I think you know what is the significance of crude oil is sold, right? When the crude oil is sold, there is no value for that. But whereas when the crude oil is processed, okay, no value in the sense there is little value. Whereas but when it is processed into gas, in the plastic, in the chemical form, then you can see that the rate is means the it gives a lot of profit. Same way, if you have a data and if you are unable to model it properly, mathematically model it properly, then you are going to lose it. You are a loser. And if you are able to encash that, then you are a winner. Same example is, I can give you the same example is with Geo. Now we are all everyone, I think okay, many of you might be having a Geo SIM. Okay, so Geo SIM was launched in the year 2016. The main motive of Ambani brothers or Ambani was that actually data is a new oil. So now they started giving free data, they started giving free SIM just to generate the data. And we without knowing, we thought that everything is free. So we started using all and generating huge amount of data. Today also we are actually generating. So he gave free of GBs of data so that you generate. So he knew that data is a new oil. So he is now accumulating oil, right? So these things, and now recent news is that the Geo company has entered into a what you call MOU with, or in MOU with Facebook. So Facebook is the platform where actually you share your interest, you share your taste, like what you like, which dress you like, what you eat, where you eat, which restaurants you like, right? Everything. See, you are not giving direct information, but indirectly you are giving all those information to the people, to the Facebook, and Facebook now it has bought 10% of the share from the Reliance Geo, and now it is using, now it is correlating the data which has been generated from 2016, and now it is using for doing intelligent analytics. Okay, now it is creating gas, it is creating plastic, it is using chemicals, it is creating petrol out of your data, whatever you have submitted. But I am very happy that I did not purchase Geo data, and I don't have Geo SIM, so I am happy that I am not into this trap and my data is not available with them. So so all those things, so those who have given, so you generated so much data to Ambani, then Ambani should be thankful to you, right? Okay, coming to the last few slides. Now I talked about data analytics. So now if you want to, I think yesterday Professor Nagbhushan sir spoke about so many domains of applications of mathematics. Okay, and mathematics was the driving force for those applications. Okay, we need computer science technology, we need mathematics, we need domain experts, because like the sir showed you an example of a medicine which was actually which was shown in the form of a capsule, which was shown in the form of a tablet, which was shown in different forms, right? And there is an injection, there are so many things which are available. So see, if you are only expert in mathematics and if you don't have domain knowledge, you are useless. Okay, so now the next future is that Now maths teacher should now start collaborating with computer experts. They should collaborate with domain knowledge person, like in medical field, like in pharmaceutical field. Now maths, see, maths is a department. Maths is a department where what can I say is that every organization, every department in the world requires mathematicians, requires statisticians. Okay, I'll tell you one example, my own experience. I was in the Indian Statistical Institute of Kolkata during the year 2012 and 2014, I guess. So my whole experience in Indian Statistical Institute, I spent there. I found out that the entry to Indian Statistical Institute, the BTech, the program, the MTech or BTech degrees which it is giving on statistics, actually there are only 30 students, 35 students. But the amount of package which they get from very reputed companies called Google, Microsoft, and they all pay very huge amount. They pay a very huge salary for these statisticians. Okay, why? Because they know how to handle the data. Okay, they know how to handle the data, and in turn they drive the business. They drive all sorts of business, computer science business, the medical business, everything. So please remember that your responsibility, if you being teachers, we being the teachers, actually mathematics teachers, it's our interest, it's our responsibility that we should kindle the love for mathematics in our teachers. We should show them applications. We should tell them to model the application. You did not solve the problem, just you give assignments, just to give creative assignments. See, your job is only to create the creative assignments. I think the e-box is a platform. E-box is a platform where this thing is being done very perfectly. I am very happy that, okay, after this lecture, you are going to you put yourself in a real domain, or put yourself in practical scenarios, and you try to solve different kinds of problems, and you will really enjoy that. So now you have listened to lecture, and now you are going to put yourself in different scenarios and try to see that how maths is applied. So this e-box has brought all these platforms together. Okay, it has brought IT, it has brought domain knowledge, it has brought mathematics, statisticians, okay, all kinds of things to means to train, and all those things are possible here. Okay, so coming to the end of my presentation, I think so. This is a joke which I searched in the internet and I could get that. Okay, so the triangle is saying to the circle that, see, I have a point, but you are very pointless. So so he is very sad. So this is how this is the simple algebra, okay, geometry or algebra. You can tell that this triangle is saying that you are totally pointless. Okay, so pointless in the sense he does not have any sharp point, right? The another example is that another joke is that at the end of the day, when the maths teacher is teaching in the class, teacher is saying, tell me, student, teacher is telling to the student, what is the value of x? The student will say, sir, janti wo meri. So in Hindi, this is I have put in Tamil because some of you can enjoy this. I am unable to pronounce. I am very sorry. So I will try to pronounce aval in Walakkai, or it is aval enakku illome. So he tells that the value of x is aval enakku illome, right? So with this joke, I would like to end my talk. Okay, thanks e-box, thanks Dr. Pradeep Kumar, thanks Dr. Punita, Dr. Bala, and the team for giving me this opportunity. I am very thankful. So I would stop sharing. Where is that?
Wonderful session, Dr. Javad.
Thank you very much, sir. So I am thankful for all the teachers and all these people who are who have listened. I hope I was able to motivate you at least something. Though I am not from a mathematical background, and I was very happy to learn about all those things and also to share with you. It's really a great opportunity for me to share with you my experience. So if
Sir, absolutely, there is no doubt you would have motivated all the teachers by covering right from the concepts of algebra, from vegetables to data analytics. It has been a great treat to all the teachers, really. So everybody is expressing their gratitude in the chat window.
I am unable. Sorry, I did not see because I am I am absorbed in the presentation. I'm very thankful for all the teachers who are spending your valuable time in listening to me. And if you have, and see, there is one request. See, I try to correlate the things with my perspective, means my domain knowledge. If you are able to see, I'm sharing you my slides. You please go through the slides, and if you are drawing some new inference, please write to me. My email ID is there, so you can just share to me so that I can also learn much from you. Okay, so please feel free to share your experience, and if you have gained, if your interpretation is something different, I would really love to know about that interpretation.
Yeah, sure, Dr. Javad. We will share your contact details to the teachers. They can share whatever know-hows they know it visually. Dear teachers, we have time for a couple of queries to be addressed by the expert. If you have something to share, anything to be clarified, you may kindly make use of this opportunity to raise your doubts to be clarified by Dr. Javad.